Today is our 50th webinar, which is something of a landmark. I can't believe how many we've done already, but webinar number 50 today. A very exciting title, Runaway Train, presented by one of our main panelists, Mr. Carl Johnson, all the way from Florida. So it's this is a very important topic. We're looking at electrical safety at work, and something that affects all of us, because we're all responsible, or we're all involved in some way, shape, or form by being involved in airfield lighting. So something we absolutely should take care of and remind ourselves at regular intervals that the risks associated with our environment and how to mitigate those risks, and how to avoid them altogether. And today's presentation is a very informative webinar on that very topic, after which you'll have the opportunity to ask your questions. There is on your screen a little chat box where you can type in your questions, so please don't be shy. The panel we have today, if you could move to the next slide, please, Carl. We have Seward Ford, who's an independent consultant, as I said, with a lifetime of experience in the airfield lighting industry. Currently working with Brett Bieberdorf and a panel of specialists from the IES to lead a group consulting with the FAA on the development of new standards and technologies and safety, of course, for the airfield lighting industry. So still enormously active and supporting our environment, our world of airfield lighting, and the airfield lighting electrician. Tony, of course, known to you all, world-renowned inventor of the PAPI, a UK scientist who specialises in development of airfield lighting solutions. The PAPI, of course, I mentioned, and working very much with the Visual Aids Working Group and the International and ICAO to develop the standards to which we all have to meet, the standards which we all have to meet in today's world. And of course, Carl, last but not least, senior aviation specialist with Avcon, over 50 years of design, construction, and maintenance of electrical systems experience, working with navigation aid systems, airfield lighting in particular, and making today's presentation. And myself, of course, Robert Shapton, Managing Director of TaylorMade Systems and TMS Training. So without any further ado, Carl, please check your tickets, put your seatbelts on. The Runaway train is about to start. Over to you.
All right, thank you, Robert, and good morning, all. Good morning. Today, I'm going to address creating an electrically safe work condition. The topic was originally presented at the annual IES ALC Fall Technology Meeting. That's the Illuminating Engineering Society Airfield Lighting Conference, Fall Technology Meeting held in Charlotte, North Carolina last October. Now, step 6 of creating electrically safe work condition includes the application of lockout, tagout devices. You'll see LOTO in a lot of places in this presentation. The LOTO is lockout, tagout. Now, before you say, geez, not another safety presentation or lockout, tagout presentation, give me a chance to explain why we are on this runaway train. All aboard. NFPA 70E. NFPA stands for the National Fire Protection Association. They are an ANSI, American National Standards Institute, approved standards governing body that writes fire protection standards here in the States, and a lot of them are used worldwide. NFPA 70E is titled Electrical Safety in the Workplace, and it's a safety standard published by NFPA that talks about electrical safety in the electrical industry. NFPA 70E requires the employer to provide safety-related training and retraining at not to exceed intervals of 3 years or sooner, as dictated by individual and project needs. Based upon what I'm about to share with you, we are in the sooner category. We don't seem to learn from our past mistakes. We just keep chugging along on our runaway train.
I'm going off the rails on a crazy train.
We just don't seem to learn. Now, OSHA is the Occupational Safety and Health Association here in the States. It's a government agency structured to oversee safety of the people in the United States. It was created by the OSHA Act, the Occupational Safety and Health Act, in 1970. And the National Safety Council is a nonprofit, non-governmental organization that also reports on safety in the United States. Now, according to the National Safety Council, workplace injuries in the United States cost employers $167 billion. That's 167 with a B, $billion in 2022 alone. Additionally, our U.S. Bureau of Labor Statistics reported there were 2.8 million non-fatal workplace injuries in the private sector in 2022. At the National Safety Congress, at the National Safety Congress Safety Expo, there's a listing of OSHA's top 10 safety violations. These are the safety violations most cited by the occupational safety and health inspectors that they observed in the field. Now, this is a preliminary list, but the final numbers have now been released since I originally presented this, but the numbers are pretty much the same as they are here. This is our top 10 list. These are the most cited violations by occupational safety and health inspectors. Fall protection is still number one. It remained at the top of the list for 14 years in a row. But I want to highlight lockout tagout. And that's number 5 this past year. There were 2,443 violations in 2024. Now, how many do you think actually occurred? Now, these are ones that were caught and cited by government inspectors. Now, do you think the government inspectors caught 10% of them? I think that's a very optimistic point of view. Think they caught 5% of them? I think that's still pretty optimistic. But even if they caught 5% of them, that's still 50,000 violations in 2024. We're on that runaway train and we don't seem to be able to get off of it. Now, the OSHA ranking over the last 20 years on this chart, the vertical axis here on the left is ranking from the first place ranking, which was fall protection, to 10th. And then each of these vertical bars show the ranking for the lockout tagout violation for that particular year in reference. Now, basically, we have 20 years of the same mistakes. Lockout tagout is ranked 5th or 6th in almost all of them. With the exception of 2012 and 2013, lockout tagout is ranked as 6th or higher for the last 20 years. We just don't seem to learn from our previous mistakes. 20 years of the same mistakes. We are on a runaway train. Runaway train. Now, before I go much further along, I've got a disclaimer I'm required to make. I have the privilege of serving on the NFPA 780 Technical Committee, the UL 96 Standard Technical Committee, the IES RP 37 Aviation Subcommittee, the ACRP 0922 panel, and I'm a AAA instructor. The views and opinions expressed in this presentation are mine and shall not be construed as the official position of any of these organizations and shall not be considered as nor relied upon as a formal interpretation. Now, my being a part of those organizations does not mean I'm a rocket scientist or nuclear physicist. There's nothing special about me. I simply volunteered. Each of you have unique experiences that would be valuable to these organizations. I'd like to take this opportunity to convince each of you to become involved with writing and updating of relevant codes and standards. After all, you and I, we're the ones who have to live with and implement these codes and standards in our daily work. Our industry needs your input. It's critical to the standard success. Now, for those of you in the States, the FAA has an advisory circular feedback page at the back of most of their advisory circulars. If you have input, today would be a good day to start. So again, lockout, tagout, the runaway train, LOTO that you see there is just an abbreviation for lockout, tagout. What I would like to talk to you about today is the runaway train of lockout, tagout. Lockout tagout is only one part of creating an electrically safe work condition. Let's think about this. We see the word lockout used. We should interpret those words as requiring us to create an electrically safe work condition. Turning something off does not make it safe. You turn it off, you go to work on it, somebody else notices the lights are out, they turn it off. Locking something out does not make it safe. Was the correct power source turned off and locked out? How many sources are there in this device? Our maintenance Bible, AC 150, 5340, 26C. Now, the FAA writes advisory circulars for us here in the States. And our maintenance Bible from the FAA is Advisory Circular 150, 5340-26C. And for the military's got a handbook titled Maintenance of Visual Air Navigation Facilities. And most of the technical manuals and the service manuals you get from the manufacturers all tell you to lock something out or tag something out. There's no real direction in these standards other than lockout, tagout. But when we see the word lockout or lockout, tagout used, we need to think electrically safe work condition. Lockout, tagout is only one step out of 8 for creating an electrically safe work condition. Lockout, tagout by itself will get you killed. We must create an electrically safe work condition before we act like the power is off. If we have not created an electrically safe work condition, we must treat everything as energized, an electrically unsafe work condition. So what are the consequences for not creating an electrically safe work condition? We've got 2 guys.
There were 2 guys. Both guys drove to work. Neither guy wore their seatbelt. One guy got a ticket. One guy didn't. Both guys drove home from work. One guy wore his seatbelt. One guy didn't. One guy made it home. One guy didn't.
Now, I borrowed this video from the National Highway Transportation Safety Administration. So what are the consequences of not creating an electrically safe work condition? So we've got 2 guys that had electrical work to do. One guy created an electrically safe work condition. One guy didn't. Both guys started the electrical work. One guy made it home. One guy didn't. That's the possible consequences of not creating an electrically safe work condition. Again, NFPA 70E is a standard published by the National Fire Protection Association titled Standard for Electrical Safety in the Workplace. 2024 is the current edition. NFPA 70E is not the law, but our Occupational Safety and Health Act uses industry consensus standards such as NFPA 70E to demonstrate that a good faith effort to comply with OSHA's General Duty Clause and OSHA standard has been met. OSHA's General Duty Clause requires the employer to provide a workspace that's generally free of recognized hazards. In addition, the General Duty Clause requires all of us workers to comply with safety and health standards. Now, NFPA 70E instructs us on how to create an electrically safe work condition. Now, while 70E is used throughout the United States and in some places in many countries outside the United States, each nation has its own standards that generally are going to agree with the concepts I'm going to cover today. So let's define electrically safe work condition. Electrically safe work condition is a state in which an electrical conductor or circuit part has been disconnected from energized parts, locked, tagged in accordance with established standards, tested for the absence of voltage, and if necessary, temporarily grounded for personnel protection. Now, realizing that we're dealing with Airfield Lighting series circuits, testing for voltage is not the correct statement. I submitted a public input to NFPA to change voltage to electrical energy, and it's in the process of being reviewed. And if you would like more information on it, if you let Damon or Robert know, I'll get in touch with you and give you a little more details on it. But that's our definition of what an electrically safe work condition is. Now, the requirements for electrically safe work condition: energized electrical conductors and circuit parts operating at voltages equal to or greater than 50 volts shall be put into an electrically safe work condition before an employee performs work. Any of the following conditions exist: the employee is within the limited approach boundary, The employee interacts with equipment where conductors or circuit parts are not exposed, but an increased likelihood of injury from an exposure to an arc flash hazard exists. Now, to start off with here, it talks about a system operating at voltages equal to or greater than 50 volts. If the system operates at a voltage greater than 50 volts, it doesn't matter if you have it turned off. The fact is that this function that is designed to operate at greater than 50 volts, you must create an electrically safe work condition. The limited approach boundary is a physical distance that we'll give a little more information on in the next slide. It's a physical distance from an exposed energized conductor or circuit part within which a shock hazard exists. And then, except requirement number 2 talks about is if you are performing a task that could increase the likelihood of an arc flash, then you're required to create an electrically safe work condition. So in this slide, it's a graphic representation of the boundaries. Restricted approach boundary is a physical distance determined by the voltage of the system. The limited approach boundary, again, is a physical distance determined by the voltage of the system. And the distances required are provided in tables in NFPA 70E. So as the voltage increases, the distance would also increase. The arc flash boundary varies. It could be shorter than the limited approach boundary or greater than, like arrow shows. And the arc flash boundary is the point at which the incident energy from the arc flash is equal to 1.2 calories per centimeter square. Now, there are exceptions to requiring an electrically safe work condition. Exception number 1 is if something is considered in normal operating condition. And to be in normal operating condition, all 7 of these criteria must be met. The equipment is properly installed, the equipment is properly maintained, equipment is rated to the available fault current. The equipment is used in accordance with instructions included in listing and labeling, in accordance with the manufacturer's instructions. The equipment doors are closed and secured. All equipment covers are replaced and secured, and there's no evidence of impending failure. So any piece of equipment you've got that meets all 7 of these requirements are permitted to be operated. So for example, if you had a piece of equipment that you needed to turn on or off in this type of operation, that would be permitted, provided it meets the normal operating condition. But again, it's all 7 of these conditions are required, not 5 out of 7 or 6 out of 7. And note that there's no exception in here for it takes too much time or it's not convenient or we're in a hurry. All right, exception number 2, an energized disconnecting means or isolating elements shall be permitted to be operated to achieve an electrically safe work condition or to return equipment to service has been placed in an electrically safe work condition. Equipment supplying the disconnecting means or isolating element shall not be required to be placed in an electrically safe work condition, provided a risk assessment is performed and there's no unacceptable risk identified. Now, if you can envision working in a panel, and the line side of that panel is going to be energized. This would permit you to go turn off the line side feed to that panel so that you can kill all the power within the panel in which you're going to work. Exception number 3, energized work is permitted where the employer can demonstrate that the task to be performed is infeasible in a de-energized state due to equipment design or operational limitations. This is one exception that most of us will probably end up using in our careers is for troubleshooting. We are permitted to do work while it's energized to troubleshoot. Obviously, you can't measure voltage or measure current to determine the characteristics of your electrical system if the system is de-energized. Now, there is a fine line between troubleshooting and maintenance or making repairs. In this particular photo, the gentleman could be making voltage measurements to determine if the fuses are good or bad. Once he isolates which fuse is bad, replacement of that fuse becomes maintenance. It's required to create an electrically safe work condition. Again, it's a very fine line between maintenance and troubleshooting. Energized work permitted where the employer can demonstrate that de-energizing introduces additional hazards for increased risk. Some examples they give us: interruption of a life support system. If you got somebody in the hospital on life support, you can't de-energize and you'd be permitted to work hot on that system. I tend to look at it as if I'm doing the hot work on this life support system and I do something wrong, not only do I have the possibility of injuring myself, this person on life support could very possibly lose their life as well. there's almost always, there are exceptions, obviously. There's almost always ways to schedule an outage so that you can turn the equipment off for you to do maintenance work on it. There are exceptions that allow it, but in most cases, the go-to should be to create an electrically safe work condition, not to work at hot. Exception 5 is energized conductors with certain parts that operate at less than 50 volts, not required to be de-energized, where the capacity of the source may and any overcurrent protection between the energy source and the worker are considered, and it's determined that there will be no increased exposure, electrical burns or explosion due to electric arcs. So that's exception number 5. So those are the 5 exceptions permitted to creating electrically safe work conditions. That was just a little test to see if you were paying attention or not. So the process of establishing and verifying electrically safe work conditions. Establishing and verifying electrically safe work conditions shall include all the following steps, which shall be performed in the order presented if it's feasible. So we need to comply with all 8 steps laid out in this section. And I'd like for you to notice the word verify. We must verify an electrically safe work condition in order to have it, to create it. Step 1, determine all possible source of electrical supply to specific equipment. Check applicable up-to-date drawings, diagrams, and identification tags. Now, I know all of you have complete and 100% accurate as-built in your storage out there. I'm saying that tongue in cheek. I would hope that most of you have some semblance of as-built, and as you update them and you recreate them as needed so that you have current and up-to-date drawings or information on your electrical circuits. If for no other reason, create them as you go so that you've got them next time. You don't have to do the same thing twice. But check all of your up-to-date drawings, diagrams, and identification tags to find out all of the possible sources of electrical supply to the equipment. Remember, our consequent regulators may have a separate power source for control, and it may be a UPS that provides that control power. Confirm identification of all power sources to the load, including control power. And our consequent regulators also contain capacitor banks, which is another source of energy. Step 2, properly interrupt the load current. Now, properly interrupting the load current, I've been to a lot of places where somebody just go over and throw the breaker. Circuit breakers are not typically made to operate as switches on a repeated basis. The standard requires us to go to the regulator, go to the remote local switch and turn to the off position, therefore turning the regulator off, then go open the circuit breaker or open the fuse switch. Wherever possible, visually verify that all blades and disconnect devices are fully open, while the draw type circuit breakers are withdrawn to the fully disconnected position. Now you notice there, even though the switch is off, this particular picture, the picture of the switch is on, but in this step, the switch would be off. You're still wearing PPE. You have not created your electrically safe work condition yet, so everything is considered energized. So you still wear your PPE until you've completed all 8 steps. Step 4, release stored electrical energy. Properly discharge capacitors, and NFPA 70 has an informative Annex R titled Working with Capacitors. Step 5 is release or block stored mechanical energy. Gravity. Is the possibility of gravity turning on a switch? Springs. Have you ever taken anything apart and springs go everywhere? Hydraulics, steam, pneumatics, chemical, all kinds of different energy sources. You want to make sure that they're released or blocked. I had one instance on a job I was on in Virginia. It was a pump storage project. It covered 25 square miles, big civil project. And they had some of the big off-road dump trucks on there, you know, the kind that you can park a tractor trailer in the bed of the truck. We had a mechanic pull one of those into the garage one day to do some work on it. He raised the bed, working between the frame under the bed. For some reason or another, he decided that he needed to disconnect the hydraulic hose when it ran holding the bed up. Guess what happened? The bed came slamming down on the frame. Fortunately, this person was able to get out of the way in time. But what he should have done would have been, if he's going to be working under that bed with it raised, that bed should have been blocked in the up position so that it could not come down. So we need to remember, we may be doing electrical work. We also need to think about all the other energy sources that could harm us. Step 6, apply lockout tagout devices in accordance with the documented and established procedure. NFPA 70E provides 2 forms of hazardous electrical energy control. Simple lockout tagout, which is one lock, one circuit breaker, and complex lockout tagout, where you have more than one service or more than one device to lock out and tag out. NFPA 70E detailed requirements for both those. Now, I would like to caution you here too, is removing your cutouts or your fuses and throw them on the dash of your truck is not a substitute for lockout tagout or creating electrically safe work conditions. I've been to several airports where they will pull the S1 cutout on the fuses and throw them on the dash of the truck, and that's their idea of lockout tagout. Step 7, use an adequately rated portable test instrument to test each phase conductor or circuit part, each point of work, and test for the absence of voltage. Test each phase conductor or circuit part, both phase to phase and phase to ground, or and after each test, determine that the test instrument is operating satisfactorily through verification on any known voltage source. Again, this is put in a public input to the NFPA to change this term voltage to energy, and that is in the works of the process. And you should let Damon or Robert know, and I can fill you in on where we're at as far as the process. Your input would be helpful. All right, NFPA 70E requires a 3-point method of testing. It's known as live, dead, live, known, unknown, 3-point test, prove, test, other names to the intent of proving that your test instrument is working properly. So you check your test instrument on a known energized source. Then you test the circuit in question to ensure that it's de-energized. Then you recheck your test instrument on a known energized source. A bad meter will typically indicate 0 volts, so it's going to lie to you. And again, notice that even though we've completed or in the process completed step 7, still wearing the PPE. Even though everything's turned off, we still treat the system as energized until the electrically safe work condition is set or achieved. Step 7, to test an airfield lighting series circuit, we would use a true RMS clamp-on or open port ammeter. The only instrument for determining if an airport lighting series circuit is energized is an AC ammeter. Again, NFPA 70 requires a 3-point method of testing to verify the absence of energy. You want to check your test equipment on a known energized source, test the circuit in question, and recheck the test equipment on a known energized source. Now, a proving unit can provide a power source in remote locations, especially out on an airport. If you're out, say, at the checking out the weather station, you've secured power to the weather station. Now you're going up to check and see if there's any voltage there. Excuse me. There may not be an energized source you test your meter on. Fluke, Megger, and other manufacturers make what they call a proving unit for voltmeters. They generate a battery generated voltage, 600 volts, 480 volts, and so on, to test your voltmeters to make sure they work. I've been unable to find an ammeter proving unit. What we do is we take a line splitter like the one shown here. I had to explain to my boss why I was buying a portable hair dryer. So I can plug the hair dryer into the Exotech. I plug the Exotech into my inverter on my truck. And I can use my ammeter to measure the current going to the hair dryer, confirm my ammeter is working properly. That's how I do the 3-point test on both the voltage or the ammeters. So in order to create an electrically safe work condition, we need to verify the absence of voltage, or we need to verify the absence of current. I can't see if you raised your hands out there or not, but I'm sure there are some in the audience who have had meters fail on them. I've had it happen, and a meter will lie to you. It'll tell you 0 if it's not working. Don't be surprised if it fails on you. How well would any of you work if you were bounced around in an overheated or freezing small metal compartment in a service truck 7 days a week, 24 hours a day? For an airfield lighting series circuit, we would verify the absence of current with a true RMS ammeter. Step 8, where the possibility of induced voltages or stored electrical energy exists, we want to ground all circuit conductors and circuit parts before touching them. Or it could be reasonably anticipated that conductors and circuit parts being de-energized could contact other exposed energized conductor and circuit parts. Apply temporary protective grounding equipment in accordance with the following. And continuing on in the same section, it tells us about the placement, capacity, and impedance of these grounding jumpers. Now, we all need to evaluate our work procedures and ensure that we always set an electrically safe work condition prior to our starting work. Until we've completed the previous 8 steps, we treat the condition as an electrically unsafe work condition. And once we've satisfactorily completed the previous 8 steps, we have an electrically safe work condition. But remember, we need to identify, remove, lock out, and tag out all other energy sources or stored energy, capacitors, steam, pneumatics, chemical, and so on. Remember, an electrically safe work condition is a state in which the electrical hazard has been removed. That's the key point here. Electrically safe work condition is a state in which the electrical hazard has been removed. The hazardous energy control is described in NFPA 70E and 120.5, section lockout tagout procedures. Occupational Safety and Health Act here in the United States gives us Code of Federal Regulation 1910.147, control of hazardous energy, and that describes lockout tagout for all kinds of hazardous energy, steam, pneumatics, chemistry, these types of hazards. OSHA 1910-333, selection use of work practices, specifically addresses lockout tagout for electrical energy. If you're interested in seeing any of the OSHA standards, they're all available online at www.osha.gov. I don't have that written down anywhere here for you to take a look at, but it's osha.gov, and it'll get you the standards. Now, again, I want to remind you that pulling this one cutout, putting on the dash of your truck, is not a substitute for lockout tagout. There's no excuses for it taking too much time. It's not convenient. I borrowed this quote from a gentleman on the editor-in-chief of the Electrical Engineering Portal. No one has ever been killed or injured from an arc flash while working on de-energized equipment. Thought that was quite an understatement. Now, what are the consequences for not creating an electrically safe work condition? One guy came home, one guy did not. Why do we spend the time reviewing and discussing the creation of an electrically safe work condition? Why must we verify the creation of an electrically safe work condition? Remember, in one of the earlier slides, I noted that we got to verify in order to create an electrically safe work condition. There are consequences for not creating and verifying an electrically safe work condition. Lockout tagout alone will get you killed. Let's think about this. Turning something off does not make it safe. I turn it off, I go to work on it, somebody notices the lights are out, they go turn it back on. Locking something out does not make it safe. Do not lock out the right power source. Again, we see the word lockout used, but we should interpret those words as requiring us to create an electrically safe work condition. Lockout tagout is only one step out of 8 for creating an electrically safe work condition. We need that muscle memory in our brains to automatically respond, creating an electrically safe work condition every time we hear lockout tagout. This is the consequences of just using lockout tagout. This is a actual accident that happened here in Central Florida, and it happened within the SIDA area of an airport. This is the security identification area. Here in the States, if we're working on the part of the airport that's after the inspection, security inspection station, we're required to have our badge visible so that people can see it. And so we're going to discuss what the consequences are of just using lockout tagout. This is a description of the accident. The utility company, the power company, and the contractor jointly lock out the transformer powering panel EMSB2. The work is to be performed on panel EQH2DP1. Panel EQH2DP1 is fed from panel EMSB2 via a 1200 amp main. Contractor opened panel EH2DP1 and began work. Contractor started removing temporary feeder cable from a circuit breaker in panel EH2DP1. Contractor's ratchet made contact between the ground bus and C phase. Anybody notice the problem? Panel EQH2DP1 is locked out. Panel EH2DP1 is being worked by the contractor. Contractor line on the back and front of the panel with a short cause arc flash event. Force the arc flash, move the contractor backwards, burns his hands and face. 2 persons were in the electrical room. Neither were wearing proper PPE. This is a close-up of the area where the ratchet, everything hit the bus. The work was in the secure area of the airport, the side area, like I was saying. The test equipment to verify the panel was de-energized was in the service truck outside the secure area. The electricians did not want to go through the security line for a second time just to get the voltmeter. This photo was taken 2 hours after the arc flash exposure in the hospital room. This photo was taken 38 hours after the arc flash exposure. Fortunately, he was wearing safety glasses. Now, the contractor gave us permission to share his story. Unfortunately, he has completely healed. But he wanted to share the story so that we could all learn from his mistake in hopes that we would not make the same mistake. This could have happened to any of us if we let our guard down. So what went wrong? Contractor failed to ensure an electrically safe work condition was achieved. Step 7, they didn't verify the absence of voltage. Now, for Airfield Lighting series circuit, we verify the absence of current. Panel EH2DP1, the one they were working in, is also protected by a 1200 amp main circuit breaker. The results could have been much, much worse. So we must confirm every time we get ready to start work that we have created an electrically safe work condition. Now, I put that sound effect on it so I could think of this thing, and every time I heard the boom, I'd think of this pounding it into my head that we have created, or that I have created, an electrically safe work condition. We can all see how easily a serious accident can occur if we let our guard down. So consequences. What are the consequences of not creating an electrically safe work condition? This is a quote from Colleen Patrick Heathrow. It says, just because we can doesn't mean we should. Just because we always have doesn't mean we always have to. And once we know better, we should choose better. So just because we always have doesn't mean we always have to. Once we know better, we should choose better. We should choose better now that we know better. Now, each year at IES, I try to present something that's a little known electrical fact, and this year is no different. So here's the little 2024 little known electrical fact. Anybody remember the first electric car? Well, probably not. First electric vehicle was invented sometime between 1832 and 1839. Batteries, galvanic cells were not yet rechargeable, so it was more of a parlor trick than a transportation device. Robert Davidson of Aberdeen built a prototype electric locomotive in 1837. A bigger, better version demonstrated in 1841 could go 1.5 miles at 4 miles per hour, towing 6 tons. Then it needed new batteries. The impressive performance so alarmed the railway workers, who saw it as a threat to their job tending the steam engines, that they destroyed Davidson's devil machine, which he'd named Galvani. Now, according to Edmunds.com, the first electric car was the 1888 Locken Electro Wagon, a 4-wheeled open carriage with a 1-horsepower electric motor, a rechargeable lead-acid battery, and a top speed of 9 miles an hour. Now, rechargeable batteries became available around 1859, and over the decades, the electric vehicle range varied greatly, but some vehicles ranged up to 50 miles. Now, believe it or not, range anxiety was a thing more than 100 years ago. Electric power is available in larger cities, but rural America was not electrified until the 1930s under the Rural Electrification Act. Kerosene and gasoline were widely available across the country, so range was not an issue for combustion engines. However, to start a car with a combustion engine required hard work to be dangerous. See the young man out here with the hand crank on the front of it. The behavior of a starting engine is not always consistent. The engine can kick back, causing disrupt reverse rotation. It could damage the engine. It could kick back, break arms, wrists, hands, shoulders. If not done properly, it could be quite hazardous to your health. The electric car was favored by women of the day because they did not have to worry about the starting of the engine. Electric car was cleaner than combustion engine. Ladies didn't have to use the hand crank to start the car. Now, can anybody guess or imagine why the electric car fell out of favor? Well, the need for electricity was driven by convenience, washing clothes, refrigerators, electric lights, and so on. In many cases, electricity was driven by the needs of women. One of these needs was met by the electric car. They all preferred it. So it caused the early electric cars to fall out of favor with the public. Well, believe it or not, it was another electric invention, electric starters. No more range anxiety or hand cranks to start the car. They had an electric starter. Starters were first installed on the Cadillac Model 30 in 1912. So it seems like the electric starter is what doomed the electric car early in the 1900s. So that's our little known electrical fact for 2024. Let's hope range anxiety doesn't doom them for another 100 years. So now I'm going to close my presentation on the creating electrically safe work condition with a little story, and then we'll have a little summary of the requirements of electrically safe work condition. USS New Jersey BB-62 is the most decorated battleship in U.S. history. The New Jersey is an Iowa-class battleship and was the second ship of the United States Navy to be named after the United States state of New Jersey. She was often referred to fondly as Big J. New Jersey earned more battle stars for combat actions than the other three completed Iowa-class battleships and was the only U.S. battleship used to provide gunfire support during the Vietnam War. Now, the story goes that one very, very foggy night around 0200. Now, for the Marines and sailors out there, 0200 is when the bars close and it's 2 hours past your Cinderella Liberty extinction. And for civilians, that's 2 a.m. The New Jersey's bridge crew picked up a radar contact dead ahead on a collision course. The New Jersey radioed the unknown contact, commanded the contact to change heading 10 degrees northwest. Now, by this point in time, you end up with a contact on a collision course. He went down and woke up the captain. So they're bringing the captain up to the bridge. And in the meantime, this unknown contact responded to the New Jersey, telling the New Jersey to change headings 10 degrees southeast. The captain reaches the bridge. He's a little bit pissed at the contact telling him that they need to change direction. He gets on the radio and speaking to the unknown contact, says, "This is the captain of the USS New Jersey, the most decorated battleship of the United States Navy. You change heading 10 degrees northwest or you will be fired upon." The unknown contact responded stating, "I'm a lighthouse. You change heading 10 degrees southeast." We are the USS New Jersey. We have always done lockout, tagout like this. We are on a runaway train or a ship lost in the fog. The lighthouse, the NFPA 70E. Once we know better, we should choose better. Now that we know we are required to create electrically safe work condition, not just lockout, tagout. Once we know better, we should choose better. In summary, when we hear lockout, tagout, we should think electrically safe work condition. We want our brain to have that muscle memory. Again, when we hear lockout, tagout, we create electrically safe work condition. Now, there are 8 steps necessary to create electrically safe work condition. We want to determine all possible sources of electrical energy to the specific equipment. We want to properly interrupt the load current and open the disconnecting devices for all sources. When possible, visually verify that all blades of disconnects are fully open. We want to release any stored electrical energy, block it. block or release stored non-electrical energy, apply lockout tagout devices in accordance with established procedure. We do a 3-point test to verify that it's dead, dead live, and we place protective grounds if they're required. We want to complete the 8 steps necessary to create an electrically safe work condition. Once we know better, we should choose better. Now, we actually want to get off of this runaway train. So I'll open up the questions here in just a minute. We had some hurricanes here last year. We got fires in California and the Carolinas and Georgia. Now there's some flooding in Europe. There's a lot of areas that are being hit with natural disasters. So I'll just ask you, the next time you see someone from law enforcement, the military, a power company, a firefighter, or a charitable organization, be sure and say, thank you. I appreciate your service. And with that, I will turn it over to Robert again.
Thank you very much, Carl. Absolutely wonderful presentation. A very important reminder to us all. We're kind of all on that runaway train, and we need to be very cognizant of the risks here and what to do about it. And I think that was very eloquently put, and just a very timely reminder, because sadly, these are practices you see, you've highlighted here. We see in day to day from day to day in the airfield lighting world, and there's just absolutely no excuse. You say this is one of routinely on OSHA's top 10 most cited violations, but as I understand it, based on the fact that this is observed violations, I wouldn't be surprised if this is not the #1 violation for the last 10 years. So certainly, every one of you out there doing it or being responsible for it, you need to take this lesson on board, because you don't want to miss the train. Be informed and be safe, as Carl says. So thank you again, Carl. If we now look to questions, but before we start the questions, just briefly introduce Tony has very kindly agreed to host the next TMS Tuesday webinar on the 29th of April, talking about low visibility operations. So we know what the pilots need, and Tony is uniquely qualified, having as a former government scientist, conducted extensive experimentation in real world low visibility conditions to understand the needs of pilots firsthand, and to have developed the standards with others in the industry over many decades to the standards that we have today. But recognizing also that those requirements are changing now with the new aircraft and the new environment and evolving environment we're working in. The changes to the visual aids, we've gone from halogen to LED, and that's going across the board for all the visual aids. We've got evolving standards. Some standards have changed and moved on a bit. Some haven't, and we need to look at those standards to move them along with the times. So we need to decide what we're going to be doing going forward. So with more on this, we will send out reminders and some hopefully energize your interest in our next webinar, the 29th of April, concerning low visibility operations and the role of visual aids in protecting the pilots, the planes, and the passengers. So I look forward to seeing you on that. But now back to today. Carl, again, thanks again for that presentation. Thank you, panel, for joining us. So Tony and Seward, also here to talk to these points. We've got some questions in. If I just go from the top. Barry's asking to do a comparison with the equivalent UK and European legislation. This is something clearly this presentation is aimed at the, based on the US standards and US requirements. They do vary from from nation to nation, but the base principles are the same. Lockout, tagout is the way forward. We're working on. You do not work on live electrical systems, with the one exception where you're troubleshooting, where there will be processes and procedures, but more of that in a moment. Any of the other panelists have any comment relating to legislation and the applicability of the different legislation worldwide?
Do I stop sharing?
Yep. Yep. So we can see you now, Carl.
That's unfortunate.
No, so the legislation will vary from country to country. Now, as Carl said earlier, one of the points we were discussing, we're very fortunate, very appreciative of the fact that in our audience we have people, suppliers, people that work at and represent larger airports and smaller airports. So we're talking from the largest large airports in the major cities of this world to some of the smaller, more remote airports around the place. Recognizing the fact that airports, the larger airports will obviously, wherever you are, you need to comply with your local laws and regulations and practices for safe operation. Your employer is responsible for the airport as a whole, but as individuals, we're also responsible for our own safety. It's not something we just blindly ignore and hand over responsibility for. We have to take care of ourselves. So it's a joint responsibility. But some smaller airports do not have the manpower and may not have their own dedicated electrical staff. So there is in the US a document published for third-party electrical contractors. Now, this is not to say this is not the be and end all for all of you and all your nationalities. You have your own national regulations, and those are paramount for wherever you are. However, as a help to airports, we will put on our website the USA document that's published for this purpose to give to third-party electrical contractors, which will contain a lot of relevant and useful information, which will supplement your local national regulations. So we'll put that on our website when we put up the copy of this webinar for you for your interest, so that that may be useful to you. So thank you, Carl, for providing that. It's used as a training program for the training TRB for this purpose. Is that right, Carl? Is there a training? There's a training TRB training program.
TRB is the Transportation Research Board, and I don't know the exact relationship, but the FAA funds it. It's part of the National Academies of Science and Medicine and another title right there. They put together panels, and then the panel will write a scope, and then they'll put the scope out for bid. What the goal of this program is that there are a lot of our smaller airports do not have the funds to maintain a full-time electrical staff. And so they may have 2 people at the airport, and they do everything from sweeping the floors of the buildings to fueling aircraft, to changing light bulbs, to mowing the lawn. And people change light bulbs at home and don't give it a second thought having the circuit on, where changing the light bulb on an energized airfield lighting series circuit can be fatal. So the goal of this program was to provide education for the I guess you say the general aviation airports, to have an understanding of what, depending on what their skill level was, what maintenance they could provide for themselves, and what maintenance they needed to farm out to a qualified person or a contracting firm, as the case may be. And then they went into some detail as far as what hazards you were exposed to. The in NFPA 70E, they have what's referred to as a safety hierarchy. And off the top of my head, I can't tell you all 6 of the categories, but the most efficient one, the preferred one, is elimination of the hazard. They have administrative controls and engineering controls and so on in the middle section. And the least effective method of protection is personal protective equipment. Personal protective equipment is designed to make the hazard survivable. It's not designed to allow the person to leave unharmed. Elimination of the hazard is the most effective means of hazard control. And by eliminating the hazard, then the person's no longer exposed to danger. So that's the whole goal behind creating electrically safe work conditions, is to eliminate that hazard.
Thank you.
Did I ramble on too long?
No, that's great. So Barry, look, each, you have to comply with your local regulations. I think I can say that for certain, you need to be competent when you're working in any capacity at an airport, and you need to be able to demonstrate their competence. You need to have the appropriate training, qualifications as required by your local national standards, and you need to have that refreshed on a timely basis, which is, I think you said 3 years in the US, Carl, yes. And it's 3 years by ICAO, and it's 2 years by EASA, and you may have different requirements for your own national operator, which means so you have to be able to the employer needs to be able to demonstrate that the people are competent to perform the duties they perform, and you need to maintain that competence by demonstrating continuous professional development and attendance at training courses, and those training courses will cover your local national requirements. So I hope that answers your question. Samuel, clearly from the USA, has just commented what an amazing ship. He's located close by, and says, he's seen it, witnessed it being restored at the Philadelphia Navy Yard. So yes, these things are now. It is just some marvelous ships out there, which I've also been to. I've also been to some of the dockyards, and they're just incredible.
I've got a little
we've had a question
for you.
Pardon?
When I was a kid, this will give you an idea. We used to be able to, when we go fishing in Pensacola Bay, we would be under the bow of the USS Antietam, which was an aircraft carrier in the bay. When I was in the Philadelphia Navy Yard for commissioning the ship that I was assigned to, USS Antietam was in mothball between 2 battleships. Now, as a kid looking up that flight deck on the Antietam, that was the biggest thing I had ever seen. That aircraft carrier between those 2 battleships was dwarfed. Those battleships were simply amazing in size. It was unbelievable how big those things were.
That's incredible. And by the way, we last year tested. We actually conducted photometric testing on an aircraft carrier. So, wow. So yes, it's yeah. We have to be very careful where we got the right stopping point. You can get. Well, we did, and so yeah, that was something that was a first for us. So an anonymous question here. As an electrician, this is for the whole panel. As an electrician, we understand the dangers involved in keeping a safe work environment. The hard part is having fellow employees or administration to feel the same way. What would be the good technique to get people with the attitude, it's just 120, nothing is going to happen, to buy in on helping build a community of safety? So how do we...
Well, you could tell them there are more people killed on voltages 240 volts and less than anything else.
Yeah.
That's across the industry. And nothing that is going to happen. There was a story on the news. I can send you a link for that one too if you're interested in it. About a gentleman working at a National Guard air station in the Midwest. He had been employed there for 10 years without changing light bulbs on a runway and was electrocuted. And again, people were thinking, well, it's a light bulb. We change light bulbs at home all the time. It's never an issue. Why is this a problem? And so I got a call from the Air Force engineer who's responsible to explaining to the general why somebody was killed while changing a light bulb. They did not understand the concept. And so, even if it's a 1 in a million, 1 in 2 million, are you willing to bet your life on the fact that you're not that 1 billion this time? So you can be electrocuted simply changing a light bulb on an energized airfield lighting runway circuit. So why take the chance?
Yeah, exactly. Ignorance is no excuse. It only has to go wrong once. So I mean, it's a matter of education ultimately, but those responsible need to be made aware. So if somebody is not, if you don't feel you're getting the necessary buy-in, then I think I would recommend that you bring the matter formally to the attention of those responsible, because I have seen at a number of airports people that actually do know turn a blind eye because they want to get the job done, and they kind of let people do things knowingly that they shouldn't be doing, and that's just unacceptable.
If it's
Just
in
a
the
word,
United States.
Stuart here. I was just going to make the word that comes to mind as we listen to all this, and as we go through life, we make a lot of decisions. And in our job on the airport, we make a lot of decisions. But the word that comes to mind is assumption. We assume in the decision-making process that this is the case, and so I can proceed to the next step. And that's the word, and that's the thought we got to have. We cannot assume anything until we've verified the situation. And that's just basic understanding, but we need to remember some of those basics as we do work in our everyday life, that assumptions can be wrong. Verify before you move.
Absolutely.
I'm
Thank
going
you.
to say something about that, because from a general point of view of the world we live in, what I see, the way particularly younger people in the community want to live, they want to live on the assumption that whatever they do is perfectly safe and doesn't have any danger in it. They're not being taught to make any sort of assessments as to how dangerous the situation is. They are saying society, the government must make this totally safe. So that there isn't an issue. I shouldn't have to worry about this, and that's very widespread in people's understanding, particularly younger people. And it goes back to parenting, where the youngsters aren't being taught to make assessments of the environment they're in and any potential hazards. So write all sorts of laws and regulations and so on. But basically, if people, younger people particularly, are not signed up to the idea that there are dangers out there, and you are number one person at identifying what those dangers and hazards might be and taking appropriate action, not assuming that the world is a totally safe place. It never can be, it never will be.
Very well put, Tony. What do the panel say to? Go on.
I got 2 points I can bring up. On one of the previous ones, if somebody's expecting you to work something hot, if it's here in the States, in the back of NFPA 70E, there's an energized work permit. And I've discovered in a lot of cases that if you take that energized work permit and ask the person who's telling you need to work this hot, ask them to sign it, It will find a way for you to work it de-energized. And the second comment I see here from Damon is that although the focus here is on 5 kV lighting circuits, there's also significant risk of loaded neutrals on commercial lighting systems. I agree with that. That's one of the reasons why on the electrically safe work condition, they ask you to take a look at all of the energy sources. And I believe the National Electrical Code requires on these lighting circuits, if they've got a multipole breaker, that they keep the separate neutral for that specific circuit. But it's hard to rely on something being done properly. You would need to address that as a possible energized source and take necessary precautions to ensure your safety.
Thank you. We've got one of the comments we had was yes, we have PPE to work on when we work on lives. We wear PPE when we work on live circuits. What do we say to those people?
PPE is the least effective means of protection. The goal of the standard is to eliminate the hazard. And PPE is not designed to prevent injury to the person. Your arc flash clothing, if it's rated at 12 calories per centimeter, then if you receive an incident energy arc flash of 12 calories, there's a 50% chance you'll end up with a second-degree burn. So again, PPE is the least effective means of hazard control. Eliminating the hazard is the most effective means. So while we wear PPE to do troubleshooting, because it's live, it's permitted to use PPE to skirt around using other safety requirements. That is not permitted.
Okay, thank you. And the next piece, this is quite a remarkable trick. We performed this quite unrehearsed in our preparatory meeting for today. And if this works, Carl, this is all on you, and I haven't prepared you for this, but I'm going to ask you a question. And if this works, Carl is going to produce something as if by magic from that runway sat behind him. So, Carl, this is the live test. I'm not sure this is going to work, but we'll try it. One of the steps in the process for safe working is to check the circuit is dead before working on it, and having tagged out and locked out, of course. Now, it has been said that you could use a ticker for that purpose. What are your comments, please?
I would say no. And for those of you who don't know a ticker, I think you can probably see.
Yeah.
No, there we go. It's a voltage check is a capacitance tester, and it works great on voltage circuits, but it is not approved for use on Airfield Lighting series circuits. Our Airfield Lighting series circuit is an ungrounded system, and David Rainey from Memphis and Stewart were involved in doing a study on this. They set up a circuit in the vault and checked it. But because it's an ungrounded system, there are certain points in the circuit, depending on the earth resistance characteristics of the circuit, where there's actually zero potential to ground. In order for this ticker to work, it relies on a potential between the tip and me and earth ground for capacitance, and that's what allows this thing to work. If there is zero voltage at that point in the series circuit, the ticker is not going to indicate there's power there. The only correct way to measure and see if the Airfield Lighting series circuit is energized is to use a true RMS ammeter.
Right, and thank you. And I know, see, Damon has, thank you. Damon has just commented, PPE stands for possibly prevent emergency, and also in the tradespeople call the ticker a widowmaker. So rely on it, and you're dying at work one day. So I think that says it all.
Like any other test equipment, though, you need to check it, give it a 3-point test before you use it.
Right. So at the end of the day, the answer is, as I think Carl said in his presentation, don't miss the train, be there, be informed, and be safe. So thank you very much, Carl. Thank you very much, panel. Thank you. So thank you, Tony. Thank you, Seward. I'd also like to thank Damon for putting this all together, and Felicity for in the background helping make this happen. A lot of work goes into these, and I really appreciate what you're doing, guys. This is all voluntary, and hugely important and valuable. Thank you very much again, Carl, for putting this excellent presentation together. Thank you again to the panel and everybody involved, and of course, thank you to the audience, because it's without you there would be absolutely no point. I wish you a wonderfully safe rest of March and the whole and future. We will be having the next webinar on low visibility operations, hosted by Tony Smith, and that will be on, remind me of the date there, 29th of April at 2:00 UK time, and whatever time that might be local. And apologies to those that have been confused by the changing time summer times that are being introduced, because I think we may be an hour out of kilter with some locations. So thank you very much. Have a wonderful month, and I look forward to seeing you on the 29th of April.
Be safe.
Carl, yeah, be safe. Thank you.
Okay, bye.
Goodbye.